Good day everyone, good day. I will come into this presentation. Here we are going to continue with science, paper 1, question B9. Okay, so now here the information is figure B9.1 shows the graph of the count rate in counts per minute against time in minutes. So we have been given this. Here there is count rate, okay, here it's time now, and also the curve here. So just seeing this, we are able to tell that this is a radioactivity. Okay, radioactivity. And when we talk of radioactivity, we say the simultaneous emission of particles from unstable nucleus. Okay, so let's go direct and see how the questions are being brought. So as we can see here, we have the first one, define half-life. Then B, use the graph to determine the half-life of the radioactive sample. C, give two effects of radioactive substances on the environment. Okay, so now the first one here is to define half-life. Now when we talk of half-life, here we say half-life is a time taken for a radioactive substance to decay to half of its original nuclei or original mass. Okay, so that is what we call half-life. So here we are saying that half-life, okay, so it's half-life. Half-life is the time taken to decay to decay by half of its original, okay, original mass. Okay, so this is the how we can define a half-life here. Half-life is the time taken for a radioactive substance to decay by half of its original mass. Okay, so this is I just define like this, you get a 1 mark. Okay, then use the graph to determine the half-life of the radioactive sample. So remember here we are saying that the original mass. So and now following this is 0 here, then the original mass here is this one here, which is 12. Okay, so as for me, I'm able to see that here the starting mass or the starting count at here it's what 12 here. So from this side we should be able to find the half or the half-life here. So when you talk of this half-life, as we know that it's half of what we have been given. So what we have been given is 12, so we can just say half of 12. Okay, so half of 12, then okay, you can just say it's 1/2. Okay, 1/2 times the total distribution here. So here now it's count rate is from 0 up to 12, so you say it's 12. Then half of this, half of 12 here, we know that is 6. So you go where there is 6. Okay, you go where there is 6. Remember from the definition, half-life is the time that we are going to find. So you go where there is 6. So 6 it's here. Okay, so here this is where our 6 is. Okay, then you draw a block line like this. Okay, once you touch this curve, you stop, then you also start dropping this side. Okay, so you draw something like this. Okay, hope you are able to see here. Okay, so it's up to this side. Okay, photo here it's not that much dark. Okay, let me. Okay, so this is the half of 12, so it is coming like this. So here I can also indicate here to say this is what a half. Okay, so here I will indicate this side to say it's half-life. Okay, I'm just indicating so that you are able to see. Okay, but this is unnecessary for you to indicate on the graph. Here it's half-life. So here the half-life is this up to this. So now the answer that you need to write there. Okay, so just doing like this, you get a half mark of what you have been given here. You have been given the 2 marks. So here the half-life, now the answer will be, so you are saying that half-life, you write it here to say half-life, half-life here. Okay, half-life, half-life is equal to, which is, this is B. So half-life here as the time it takes for this radioactive substance to decay by half, it's what, 2. Okay, so now you put 2 minutes. Time here is now in minutes, so we just say 2 minutes. Okay, 2 minutes. Okay, this is how we can answer B, which is half-life. Using this graph that you have been given, you just first find the half of whatever the distribution that you have here. So here it's 12, half of 12 is 6. Then 6 here, you get what? Time here. So the time is 2. So here we'll say half-life is equal to what? 2. You've used your graph to answer this too. So this is how you can answer. Okay, thank you. Then we proceed. Give 2 effects of radioactive substances on the environment. So now here is just to give the effect of this radioactive substances to the environment. We know what radioactive substance can do to people. It can cause gene mutation, it can cause cancer, so on and so forth. So now here it's just on the environment. So it's when we talk of environment, let's say here now radioactive substances can cause what water pollution, can pollute what water bodies. Apart from that, can also affect can affect the plants. How does it affect plants? By polluting the soil again. Okay, by polluting the soil, which means the plant will not be able to get enough nutrients. Therefore, soil may die. Okay, so here what I can write here, it's this, we are saying that the effect of radioactive substance on the environment, one, cause water pollution. Okay, so causes water pollution. So radioactive substances, they cause what? Water pollution, or they contaminate water bodies. They contaminate water bodies. Okay, then apart from that, they also reduce, or they affect the growth of what? Plant. Okay, they affect the growth of plants by, so they cause what? So pollution. Okay, so we are saying that radioactive substances, they contaminate, just say contaminate here, contaminate what, they contaminate soil. Okay, so causing pollution, which can also be called as land pollution. Okay, so now this is how I can answer this question. If any question where you are not clear, please feel free to ask, and also feel free to contribute. Okay, thank you.